Hello, everyone. Let's wait for another 30 seconds until we can start the session. I see that people are joining. Thank you very much. Okay. Hello to everyone. Thank you for taking the time and joining our session today. My name is Eitan Segal, and I am your presenter of the session today. So first, let me go through some general session points before we start. This presentation, along with other materials that I uploaded, will be published once the recording will be ready. You have also the chat window on the right side, so you can ask questions. So feel free to use it during the session, and I will do my best to answer all of them, till the session ends. And last point, my details are listed here, so you are most welcome to get in touch for these discussions. So let's start. So let's go through the agenda of today. So today we're going to discuss how IT is going forward as a business enabler, what it really means, like new type of metrics that customers are trying to capture in order to focus on new type of ways to deliver services to their customers. We'll go through the added value of Hyper Converged, what it brings to IT, to the business, as well as we'll review some different type of consumption models. So at first, I think the most crucial is really to understand, the landscape, where we are. So I think it's very familiar to all of you. We are continuous, hearing from businesses that we need to quickly deploy application. We need to move faster. We need to optimize, our infrastructure. We need to deliver systems as a service, and that actually poses a huge challenge on IT. In order to quickly adopt or change the current infrastructure way they deliver and operate in a way that fits the current age of change and the competitiveness that each of our companies are facing as of today. So this really drives seeking of a different type of delivering models, as well as new type of technology that really helps in order to cope with these new age and new type of requirements that we see day by day. So I think the first thing that we need to do, and actually we see a lot of customers going to that mind shift. We think that as well as we saw it starting to evolve, is customers increasingly need to focus on differentiating themselves from the competitors. So to do so, today's IT must embrace the modern data center and break down silos of complexity and streamline its operation to keep pace with today's on-demand businesses and culture. But we think that successful customers target investments in areas where they can really drive differentiation against their competitors. And actually, infrastructure isn't one of those areas. So in our opinion, customers should instead focus on, getting infrastructure operational as quickly as possible after it arrives, enabling business application, making infrastructure growth transparently, so to the need of the application owners, and really streamlines all the services right in the fit of their demands. So the question becomes, should IT focus on integrating together all the technologies and components required to build infrastructure, or should they spend the bulk of their time and resources on business innovation, choosing instead to buy and consume engineered solutions that provides the speed, agility, and simplicity required to compete in today's digital economy. So we started to see change in perception and change in the way how our IT start to, let's say, benchmark and list new type of KPIs that really look for how change of infrastructure, technology, and operation will really impact and create gain on recurring business values. So and then we see that most of it starting increase of the IT departments, they are not just focused on the started hard saving metrics like sudden cost reduction, but more on cost avoidance, cost that can be really quantified and measured, but won't be directly reflected on the balance sheet showing, a delta from a year prior. So the fact, they can accomplish more IT projects with fewer FTEs because of the efficiency a new solution brings, will really without adding, headcount, which, would never be, possible with prior infrastructure, or more importantly, quantifying the improved infrastructure reliability the solution delivers. So both, the productivity and revenue gross margin are key drivers to that change. And there's actually these metrics will really now are the factor of choosing the right technology, the right solutions in order to be the business enabler. So things like, how many projects, I'm delivering per year, how many new initiatives, the IT department is now focusing to enable new type of businesses and also go and meet the customers, the business owners, and to think of way we can improve, solutions, technologies, and services, and reduce time to deploy different type of aspects, if it's the infrastructure, or if it's applications, or task cover area. So overall, these are the metrics that now customers really looking for solutions and technology that they want to implement, and not just the hard cost saving of the capital cost of that new solution. So as we saw in the previous slide, customers are seeking for new ways to support the business needs, and hyper-converged infrastructure is actually one of the key technology that enables that and accommodates that requirement. So if you look at the slide, there are 4 key drivers for the adoption of hyper-converged infrastructure. The first one is the lower of TCO. So lowering TCO, the total cost of ownership, is a major factor. So it's of course, there's a saving in capital, initial investment, so it's much lower compared to a traditional, SAN, but also, the operational expenses are lower, if you compare that traditional SAN architecture. This includes, cooling, power, ongoing, system administration, elimination of fault-free upgrades and data migrations. And the second is, the speed and agility. So as I mentioned before, the metrics of how fast I'm delivering something is really the key that we are seeking when we talk about speed and agility. So the faster time to value of deployment is really where you can measure, how easily it is to add, component or resources, if it's storage or compute or networking, to meet the business demands as you grow and expand. The third aspect is really scale and the ease of use. So, hyper-converged infrastructure, allows users to start with, a very small deployment, several nodes, and then flexibly and efficiently scale out to support dynamic workloads and evolving, business requirements. So you can go from 100 nodes to 1,000 nodes, depending, on the system type. And we go through the type of hyper-converged platform we have today and how we can accommodate things like 100 and 1,000 nodes, as a whole infrastructure. And I think the last but not least is the operational simplicity. So hyper-converged infrastructure is also managed from like a central console. It controls both the compute and storage, and automates many functions, which is also driving customer interest because it helps cut down on the number of tools that have to be learned and also used. All of these increase the capabilities to start small and scale, but make moving to software-defined easy and provide the lower TCO. So the next thing, so how really you can pick the right solution for you. So what type of solution is fit for your purpose? So ultimately, it really depends on the use case and the requirement of the application environment. And I've been asking this question a lot on different type of technology. And when I start saying depends, people are, saying, so it again, but yeah, it really depends. So if you have, for example, a remote small data center and edge locations, and you don't have like highly skilled like IT administrator available, then a hyper converged appliance could be a great option. You simply, set up an highly automated appliance, delivers, simplicity and speed at a, relevantly low cost entry, compared to the most like standard reference architectures or traditional SAN. So, appliances are very, highly configurable, and are designed to start small and grow by simply adding appliances or nodes, as we call it, to a cluster. They provide a buyer experience which is, exclusive of, ongoing lifecycle management and support. If you go further to a rack scale, so a rack scale system, brings the same benefit, but as the standalone appliance, but on a larger scale. So core data centers are perfect choice because, like their name suggests, they can scale bigger and easier than standalone appliances, because they include the networking component. And again, it's, the buyer experience is, hyper converged, software defined, but scaled to really extreme, without difficulties. But, if we look at it, we also have, let's say the traditional concept of converge, which are, fundamentally a bit, different, than hyper-converged architecture. But they bring together, best-in-class, hardware and software components, so like compute, network, storage, visualization, and management, to greatly simplify data center operations. So these systems are built for a modular design, which make it easy and flexible to scale with the core data center. And they also offer rich data services and highly resilient infrastructure component, which if I summarize, it's more for like infrastructure resilient use cases for monolithic application. And this is actually a great fit and support for, very high-end mission-critical enterprise application. So, but even though traditional converged systems have, also proven, to deliver, excellent TCO. So, although converged and hyper-converged solutions are, proven significantly, to speed deployments, improve agility, they deliver high availability and really simplify, IT operation. Many customers still have, traditional silo of IT organization with different department responsibilities for a specific area of the infrastructure, like server towers, network storage towers, etc. Each with its own, view of resources and operation. Likewise, some customers may, still consider software-defined storage or hyper-converged solution to be like not ready for enterprise consumption. So this is why I wanted to give you a brief of, the standard, let's say the different type of, consumption model there is today, in order, to deploy hyper-converged solutions, and, what are, the options that we can have. So I think the first one is, the standard, validate solution, or we call it like the reference architecture one. So this is more like for the IT organization who want to choose, the components, and build the solution by themselves. Customers, they must supply, the servers, the switches, as well as, the internal expertise to architect the solution and operate and automate and integrate it with the, internal infrastructures. That can include, just, software only approach or hardware software bundles, and, and accompanied by, professional service and support, but all the heavy lifting of the integration of the build. So the design, the build, and as well the ongoing running and the lifecycle management of that infrastructure is all based about, on internal infrastructure resources. If you go to the appliance buy option, so it's like a fully integrated, pre-configured and pre-tested infrastructure appliance, and it delivers, all-in-one like IT infrastructure for customers moving towards software-defined data centers, which also brings the power of, the whole SAN, for example, just 2 racks, with 4 nodes. Providing a very simple, like cost-effective, hyper-converged solution for a wide variety of application and workload, as I mentioned before, with the small, medium, use cases. Then we have a buy experience for the rack scale, which is a fully integrated rack scale solution that includes, the software-defined storage, with full integrated rack scale spine and leaf network fabric, this is the key. So specifically, I'll go on that, in later stage. But the networking infrastructure in a very high rack scale solution is one of the most important or key components that needs to be addressed from a design perspective and from a build perspective, as well as in the ongoing growth. And this is part of the added value when you buy a rack scale system that provide that. And also the fact of the rack scale has like a distinctive advantage, versus the standard Hyper Converged appliances, because it manages all the growing and all the expansion of all the component in a very linear approach. So the extension of the network and all the components and the racks as well as part of the whole solution. So going forward, so your needs and requirements will really determine which model is the best fit for your environment. So if you want to maximize flexibility and decide to build the infrastructure from component, then the reference architecture model can provide value. You pick all the components, and based on that you can based on your people and expertise, you can figure out how you can bring all these components together and make sure the components work. So it comes from some engineering validation process based on reference architecture documentation, but ultimately in order to test it or validate and configure and put it in production, it's all on you. And expertise for all of these components, and that can vary greatly from networking, storage to virtualization and compute. And then I think that's the reason when we see customers where the IT is still based on silos, they really continue to think in that way and to continue to go towards the build process rather than the buy experience. But now we see more and more customers shifting and really using that assets in order to bring other new stuff and other innovation, and not just using all the people and processes in order to run all the life cycle process of every new type of infrastructure that they want to introduce. So then if we go back to the use case of the remote and small data centers, so then in this case, when you want, it's a very fit place when you start very small. This is why Hyper Converged fit nicely, because it's a low entry cost point. It's also low footprint and really reduces all the effort that you need to put in place when you want to deploy this in remote offices. And this is a perfect fit for that. And again, as I mentioned before, in the rack scale is really fit for the large core data center environments where we really create a common platform in order to support different type of infrastructure as a services, as long as a new type of platform as a services that can be shared across different type of business units, customers, and use cases. So to share that, like some options that are out there. So and while appliances are great, and as I mentioned, they're very small for medium-sized deployments, and I think the top of it is more or less like 12 or 16 appliances, roughly between 48 to 60 nodes. But if you look of creating or developing a common platform that will support different type of application workload that even from mission critical ones, and also initiating new type of application development, in this scenario you'll need to go for a much larger concept, which is more from the 100 nodes options. And at Dell EMC, we then develop a whole family, which we call a VX rack system, that really fits on that purpose. So the VxRack system really consists of hyper converged rack scale engineered system. So we integrate the networking to achieve the scalability and management requirements of traditional and modern workloads. The VxRack family is also purposely designed to enable you as a customer to quickly deploy infrastructure as a service or private cloud architecture. And then you can gain, and be in let's say the speed of your businesses in a way. So you can seamlessly grow, and by growing, you can reduce the cost and risk, by if comparing, buying versus building an infrastructure platform, that can also support traditional business application, or can deploy cloud native applications. Customers, can choose different type of, VxRack system that, satisfy the specific application environment required, and we have different type of, personas that I will go through in a minute. But I think the key, focal element is that one, it has fully integrated networking. So it's architected for like extreme scalability, a fully integrated network rack scale spine and leaf network, as I mentioned before, with a pre-integrated physical networking which is included. And this is really one of the key distinct advantages at scale versus like hyper converged appliances that leaves, all the networking domain outside the system and the support boundaries. So you have a fully engineered, maintained networking domain. You have an easy way to extend and expand the infrastructure. And that, build of networking really reduces the need for silo expertise, and also eliminates, the complexity of the design and the integration pieces. Also, the main factor is that network design and components really support the superior performance at scale. So when you grow with your compute nodes and the storage node, so we can go from compute power and storage capacity and storage performance, and continue now today when the all-flash technologies, you have very architected and tested network infrastructure that can grow and scale as you grow with your components. And the second piece is very simple to manage and upgrade and sustain. So, the complete life cycle management is really to, simplify, hardware and software releases and upgrades. So we have for that, software, the Vision software, that provides, the intelligence and, automation and a way to visualize, all the component inside your hyper-converged and converged infrastructure, so you really know where you are from, patch, lifecycle of driver components, and all the integration pieces between the hardware and the software component and the whole rack, which I think is the major key in respect to the run phase. So all the maintenance life cycle of the updates of the evolution of the component, both the storage and so the software and the hardware, are tightly coupled, in a management layer, which we then can, review, and then you can apply, that upgrades in a very automatic fashion, and to see all the components and all the release that you need to apply. I think the third is actually, the way, how you can start. So as the concept of Hyper Converged, you have the same concept in the rack scale. So really can, start small and scale big. So you can start with very few nodes and can rapidly, scale to hundreds, over 1,000 nodes. Scaling does not diminish, with enterprise-grade performance or resiliency. On the contrary. And the last but not least is the workload flexibility. So, the VxRack systems, they offer three type of flavors. We'll touch base in a second, which is like all traditional or cloud native application running, on any platform. And we will go through what type of personas we have in the VxRack system that will allow you to be flexible on supporting different type of services, initiatives, or business requirements. So as I made, but personas, the rack scale family has three type of personas. So each which leverage different software stack to address the unique requirements of both the traditional and the cloud native workloads. One, we call it the SDDC node, which is purpose-built for IT organizations that have standardized on VMware software-defined data center, and want the best foundation for a wide variety of enterprise workloads. Ideal for a VMware-centric enterprise data center and service provider, that once require a turnkey VMware-based private cloud solution, optimized for a wide range of traditional enterprise workloads, which include all the the VMware vSphere Enterprise, Virtual SAN, NSX, and key components from the VMware Relay suite. And the VMware technology are really used in data centers at hundreds or thousands of mid to the largest scale organizations. So really, it can scale very big, and customers really can gain a single pane of glass visibility and control from the physical asset as well as the virtual resources. The second one that we have, we call it the VxRack Flex, and the reason we call it Flex because very flexibility. So Flex leverage that EMC scalar software defined storage with enterprise grade resiliency. So to create flexible open and heterogeneous foundation to deliver infrastructure as a service at scale. It provides the scalability again and the elasticity and flexibility and performance for enterprise data centers. It can support the same things, so traditional platform 2 enterprise workload as well as heterogeneous sets of like abstraction models, and the performance really scales linearly. So the more nodes you add, the more the system provides more more performance. And I think the third persona is the VxRack Neutrino, which is a turnkey enterprise grade cloud native infrastructure as a service. This can be deployed and based on OpenStack component, and in the future also the VMware with Futon, and be deployed in just like a few days with built-in automation as well as dynamically ability to provision resources for the first time in less than 1 hour. It's very ideal for enterprise ISVs, mid-service providers, or customers that want like an on-premise private cloud to host cloud native platform 3 application, but lacks the OpenStack expertise in-house. The software automation layer includes very robust monitoring and reporting. You also have a single-click software upgrade for the whole OpenStack stack. And have single vendor support for these open source and cloud native infrastructure as a service and data stacks, and also automating very complex operation tasks that typically require rare very deep and expertise. And this actually provides a very good foundation for multiple cloud native services. Includes like OpenStack today, and as I mentioned, VMware, Futon platform, and Apache Hadoop, in the future. The 3 type of personas that you see here are also part of our foundation for our different type of solution hybrid cloud. So we have the E8C, so the enterprise hybrid cloud, that is based on the VxRack SDDC as well the VxRack Flex, and we have our native hybrid cloud, the N8C platform, which supports the third application development platform that is based on the VxRack Neutrinos. So all of these components are really the base of all our hyper cloud infrastructure solutions that you can purchase, or we can also have it installed on premise and managed by you or by us as well. So if we go further on to dig a bit on each of them, so just give some a quick review on the three personas, so the VMware stack, heterogeneous general purpose one for the Flex, and the plural native apps. So when we start on, the SDDC, so it's based on your VMware Evo SDDC software suite. And I want to touch base on a few details so so the Evo SDDC brings to validated software suite of provides interoperability, testers component that us can leverage to deliver complete integrated system, and that system is take advantage of qualified hardware components and also the pre-built and pre-racked provisioning and appliance-like experience. That really makes it very easy for you to consume and deploy and operate. Using Hyper Converged infrastructure as a building block, the Evo SDDC delivers really a complete SDDC stack for compute, networking, and storage from the hypervisor on a scale-out x86 server platform. So the system really delivers an easy way to deploy agile and scalable higher performance infrastructure, which has also add the network virtualization and automation capabilities. So this solution is really integrated with VMware NSX, vSphere, as well as vSAN, along with all the automation and the management operation of the vRealize operation and vRealize log insight. You can also add virtualized automation for service catalog as an option, and to make it, what is also unique and new is the Evo SDDC Manager is really the software layer which manages and automates everything within the stack. So it includes the hardware from top to bottom, reducing deployment of these large-scale systems from days to hours. And also it intentionally, automates the common tasks associated with, server deployment, as well as with ongoing management and operations. So all the process of powering up, provisioning nodes, monitoring virtual and physical assets, and also all the networking components in the top of the rack, spine switches, etc. So they have a one pane of glass on managing the whole stack, including the day one operation of the first initiation deployment, as well as the day two operation of continuous monitoring and management of the operation and the support and the performance and the capacity management on the whole stack, with the visibility of the nodes, the physical assets, as well as the virtual one. If we go to the Flex one, so the Flex is as I said, is very flexible because you can install it on different type of hypervisors and operating system, and to support different type of clouds. So the Flex leverage, the scalar software, to virtualize, the direct, attached storage into share pools. So you have a wide distribution of data for massive performance. So the software-defined storage scale.io piece is really distributed data across all the storage resources in the cluster, which really eliminates the architectural problem of other IP-based storage system. All the IOPS and the bandwidth of the underlying infrastructure are realized by balancing it with no hotspots, and you can have a shared infrastructure across different type of components. So, example, you can have a VMware tenant, a KVM tenant, and a Microsoft tenant across the whole huge cluster, and you can have multi-type of different aggregation or segregation of resources, and you can have a common platform that will support different type of hypervisors, operating system, as well as different type of clouds on top. And one of the unique key factors for that is the way that Scala has its built-in multipathing, because it's really distributed traffic across all available resources. So every server can be a target as well as an initiator. So it means it can add, remove nodes in the cluster, and that multipathing will dynamically update on the fly, and dynamic built-in multi-platform really create that scale or common platform that can support every type of tenant that you have, in the environment. And go through the last persona that we have, which is our neutrino. As I mentioned, is a turnkey cloud native based on enterprise-ready OpenStack, and also is ability to be the foundation for a pivotal cloud foundry. The unique here is that you have an infrastructure in a box based on OpenStack, ready to be used, ready for live operations. And you can add like fast provisioning. You have a central UI that you can provide, infrastructure as a service catalog. You have ability to really lower, the operational expense, because we simplify all the process of how we scale with the Hyper Converged node in with the whole OpenStack infrastructure. We also created like enterprise-grade software, so for all the cloud-native applications, as well as we are also supporting in the future, multi-cloud stack. So in the future, we'll see VMware Futon as also part of the same neutrino family, and it's really a true turnkey open source OpenStack. It's really easy way to upgrade, and really helps customers to gain to embark towards a third platform in infrastructure, in reducing all the complexity of integration in the OpenStack world, the components, the scalability, and also the extensibility for other servers, which is coming future in platform as a service, and databases as a service, etc. So the key is really how we automate the provisioning, a whole OpenStack environment, and how we can really reduce the complexity of the service management, and really in a compelling economic way. And all of that, so all the concept of the converge or the hyper converge, so all the experience of buying and converge infrastructure, or that if it's hyper converge, if it's converge, is really tied up for the 5 key areas, which is engineered, manufactured, managed, support, and sustain. But I think to really simplify and to understand what the value out of it is, really all comes to the design, build, and run process. So every time that you define a new architecture, you want to build something, first thing is you design the architecture component, you then put all the components together, you integrate it in a way, you validate that the integration works and all the components can work seamlessly with each other. Then that system is valid, and then once you deploy it, then you start to run in the whole run phases from day 1, day 2, day 3, and day 4. And the way that we are building or designing the converged infrastructure is really to think about all the integration that is needed. So the best of the design architecture using the best technologies, and then engineer them together to provide a seamless user experience of consuming this infrastructure. And by running all the test and validation processes that we do, we're making sure that infrastructure can work seamlessly, and the performance and all the requirements that we set to as our goal. And hence that really change how you consume the infrastructure, and also help you in the long run rate of the life cycle of the infrastructure, when you need also to update and grow from different type of software components and drivers, etc. You have the ability to do so with our RCM process, where and based on the vision software as well, when you have the one pane of glass that you see all the components and how they fit, and what you need to do in order to increase or change part of the software version, etc. So in order to give you like a last summary of the added value, so, and this will be also part of the attachment that I mentioned in the start of the session, is this finding is like the 6 key general findings part of like IDC report that went through customers that use EMC Dell Scala software as well as the VRX system, and this is the key factors which comes back to what I've been talking in the first section where we discussed about the key metrics of business values. So then if you look in here, this is actually the same key metrics that we asked our customers, and then this is the major one. So faster application deployment, unplanned downtime, which means increase of productivity, faster storage deployment, as well as cost of operations. So all these metrics come back to what we discussed in the first, as well as of course, when we invest money, we need to understand from our perspective, first of all, how much time it will take us to buy back, and as well as what are the added value from an ROI perspective. So this is part of the metrics that was during the study that our IDC conducted, but you will definitely can go through the whole pages on the document that I will share, and then you can go through all the areas and the detailed use cases and metrics and scenarios that have been asked and checked. But overall, just to summarize, the use of Hyper Converged is very appealing because it really drives us to support new initiatives, way as IT to really be a business enabler, and really provide us the means to really create common platforms that really can drive efficiencies and to drive more agile way to support business requirements. And also to give you the glimpse, also the view of mind shift changes, the value added of the different type of consumption models, the value of purchasing, buying an infrastructure ready to consume rather than building by yourself and using a lot of efforts in order to do so, and also the added value of different type of use cases you can think of using Hyper Converged as the baseline for that. So if it's like the traditional workload, the infrastructure standard as a service, as well as the third platform application in development, as I mentioned. So these three personas is actually the three major environments/use cases that we see of today, and this is why we brought these type of personas to the market based on the requirements, needs, and also the attraction that we see and the growth rate of these areas that we see along. And also going forward, there will be a new type of technology, new type of rack scale technology that we will showcase in the near future as well, that we can also increase and provide more new type of things in this area. So this, summarize the session today. If you have questions until the session ends, so feel free to put any comments or feedback. Will be happy to receive from my side. It was a pleasure to be in the session today and discussing this topic for you. I hope you find it interesting. Feel free to share your thoughts, reach out by other means of email or LinkedIn or other social options. I'll be happy to continue and discuss these topics with you in the further. So hope you had a pleasant session. Thank you very much for joining. Appreciate your time. Wish you a great day, and see you next time on the next Brighter session.